Okay, hello guys. We'll get started. This is our stream. So many coding problems. Okay. Mhm. So today my plan is to solve dynamic problems, but I'm going to more focus on the hard problem. The first one that I want to pick is the longest increasing subsequence. So given an integer sequence, return the length of longest increasingly subsequence, right? So basically, now here the one way that I can do this with, I can take two parameters. So I want to quickly solve very using that. So either you have taken a left element or you have not taken a left element, right? So public and solve and nums and I and j, right? So and n will be your nums dot length, and if I is greater than equal to n, then you basically return 0. Now, and option 1 is 0 if option 2 is also 0 if, let's say, j is not equal to -1. That means that you have already taken something. So if nums of I is greater than equal to nums of j, so strictly, so it should be greater than, right? Then you have 1 where option 1 is equal to 1 plus all nums, where I becomes I plus 1 and j becomes I, right? If you have not taken, right, then another thing is you can uh, so this is one thing, right? If you have taken already, right? Then option two would be that you don't want to make this decision. You say that I'll go further and keep the J same, right? In the else scenario, you have basically have one option. You have two options. You basically take this and you say that, okay, I've started and this is my I now. Option two is basically, so here when you say option one, right? So here, right, you didn't start anything. Your J is negative. So this is like just one element that you're picking up, right? Or you can say that no, I don't want to start at all. We'll keep the J same. So return math.max of option one, option two. Uh, First we'll check whether it works or not, right? If this gives a TLE, yeah, if this gives a TLE, then means it works because I have not memoized it. Because there will be a lot of cases that I'll be overlapping, right? That's the concept. So yeah, if now I do public integer dp and dp is equal to new integer, uh, yeah, new integer nums dot length, right? So if nums of I comma j is not equal to null, So sorry, I got distracted. So DP DP of I comma j, and then DP of I DP of j. So I'll use +1 here because I'm using 0 also, right? That means I need to use +1 here also. It could get tricky. It could get tricky if not equal to null. See again the same thing, right? Hmm. See, now this is the easy part of it, right? Now there is another way of solving this, and also so I have meeting, so I'll need to start top, not top timer, right? This is very bad. The real time. Yeah, so basically 30 minutes from now is like, yeah, that is good enough. So, okay, mm, this looks better. Okay, so what I was going to say is that, give me a second. Uh, I was about to do one thing. Mm, okay, so this is n-square solution, right? Our aim is to find something better. That is the goal, right? This is n-square. Now, to find something better, there is actually a very, it is a trick. It is hard to come by. I already know it, but I need to revise it. So the concept is like this, that you use binary search basically because we only care about the length, right? So you maintain a sequence. Initially, your sequence is empty, right? The element that you have is 0. So first, let's say you have 10. Then the next element, if this element in your sequence is there or is less than, if this has an index in this, Because what would happen is you'll form 10. 1 second. So you'll form 10 and 9. That is the another sequence, right? But this is not increasing. So wherever you were going to use 10, you can basically use 9, right? So I can say that, okay, all I have is 9. Then you have 2. Again, nothing is increasing. You can just say 2. Now 5 came, right? So you can have 2, 5. So I'll put 5 here. Then 3 came. Now either you can have 2, 3, or you can have that's the only thing, right? So you again change. So you make it 2, 3. Then you have 7. So 2, 3, 7. Then you have 101 of no point. You can just add it there, right? 18, you can change it with 18. So basically, if the element that is coming, right, is greater than your last element, right? If let's say it is greater than your last element, you just add it to the end, increase your sequence. So two cases, if greater, add in the end, right? Now if it is not greater, right, it would be either in the middle somewhere or it would be smaller, right? So if 1, 2, 3 is there, if 10 is coming, right, it would be smaller. But if let's say 0 is coming, then I can, now if the 0 is coming, I already have 1, 2, 3. I can't change the first element, or can I? So 1, 2, 3, 0, let's say 1, 0, 4, right? So we are saying that you change 1, this is greater, now this is smaller. I'm saying that you can put 0 here and then you can put 4 because that element is already there, right? Why this 0 would work actually? Because you already have an element that is less than that, so it won't create an impact. So how this will work, right? So we basically need a sequence, right? Now the thing is that uh, as of now, this sequence would have no element, right? Int element is equal to, yeah, here we can say int index is equal to -1, or we can say 0 also. Let's say it -1 only. Now for each element, int place at binary search, you need a sequence and you need index, basically where your number is, right? And your what is the element that you're going to get. So public int binary search, int sequence, and int index, and int target, because always it is better to call it. Now if index is equal to -1, right? Then I'll handle it separately. So I'll just say that sequence of index plus 1, which is 0, is equal to target because I don't have anything anyway, right? And then index plus 1, index plus plus, and then I return the index of it, right? So basically, place it, return the index. So this is placed at 0. Now, if this is not the case, right, then I need to find. So int low will be 0, int high will be index, right? Because those are the elements that I have. and int place at will be -1 for now, right? Or it will be index plus 1, assuming that it is the greatest. It is the greatest. Now, while low is less than equal to high, int mid is equal to uh, high minus low by 2. So this is 2 high minus high plus, yeah. Now, if sequence of mid is less than target, then I need to go to right. Right, so basically you mean that low is equal to mid plus 1, right? Worst case that I'll never hit anything, right? So here I can say that also, that answer is going to be this. But else if sequence of mid is less than target, if that element is greater than target, right? So basically what is happening here is 1, 2, 3, 4, 5. Now sequence of mid is greater than target. Right. Well, I mean, if you have to think of it as like let's want to put 2 here, right? So this 3 is greater than target, right? So in that scenario, we can basically say that you need to go to the left side and the answer will be sequence mid because you can place it there, right? And then your high will be mid minus 1. Now there could it will always come here if the everything is less, right? So that's why you don't need to basically do anything there. But here also you can say this answer is equal to mid. But no, right? Because you have to find the end. So now this is the scenario. Now if let's say it is same, what to do then? Let's say I have 1, 1, 1. So if it is same, then you have already found that index, right? Then you can just return because if you have a same element, it doesn't mean to do anything, right? Just break it. No need to do anything here. So if it is same, then you don't need to basically do anything, right? Here you can just say that there is already that same element that you already have. Or what if it is like 1, 1, 1, 2, 3. So you'll start with 1, again 1. So here you'll put 2. I think you don't need to do anything. So you can just break. So you can just return the same. It will remain the same index, right? No changes to that. Otherwise, now if it is less, right? So my idea here is that I will already make the changes. Here I already increased the sequence, right? Here also I can already do that. If it is greater, then so basically now you can do that is sequence of place at whatever is the place at, right? So your place at is going to change. Place at is going to be target, right? And then if place at was greater than index, still greater than index, then you do index plus 1, right? Basically, you don't need to use it, and then you return. And then you basically return index every uh, return index. I'll take a break, guys. Quick break. Yeah, let's see why the error is wrong, right? So minus one, minus one, minus one. Everywhere minus one is coming. So sequence is minus one. Okay. If index is minus one, you saw that index. Okay. So basically, here index is what will return. Now let's see. So 3, 3, 0. So it's the difference with 1, right? So if I start with 0, start with 0, what now? Correct? Because by default it is 0 based, right? So you have three elements. A better way would be to, let's say, you keep that only and then you return 1 over here. See, when you have found something, it doesn't make sense, you change it basically. Now I want to test it for something very weird. 10, 10, 10, 10, 11. Answer should be 2. Yep. Let's see. Awesome. Proud of myself. I've done this after a long time. Still able to do it. Yeah, that's the thing with DSA. If you if you leave it, it'll go away sooner. Like gym also, right? If you don't go to gym, your body will muscle will go away. So that's the thing, guys. Okay. Uh, I feel like I have an obligation to code. There are a lot of good teachers out there. It has evolved. When I started, there was no, you can say, resources or things were less. But now there are a lot of good resources. The aim of this stream is just to be there. Someone is already doing it. You guys can join solving. As of chat is empty, but I want to make this stream mainstream. that everyone should be doing this at least 10 minutes, 20 minutes every day. It would be awesome. So let's see which is this problem. So given an array, return true if you can partition the array into two subsets such that sum of the elements in the both subset is equal. So basically if the total sum is odd, it's never possible. So int total sum is equal to 0 for int nums total sum plus num. Because you see, right, you need to split. It could be 5 comma 6, right? If total sum modulo 2 is not equal to 0, return false straight away. Now the second problem it breaks down is to need int target, let's say. Target is equal to total sum by 2. Basically, you need to find uh, element array in this such that its sum is this, right? And it has to be a subset. So basically, it doesn't has to be uh, occurring, right? Now, to subset, now there is a thing, right? You need to make that. Now, base, and also we need to think of it like 1, 5, 11, 5, right? So the total sum comes down to 1, 5, 6. So this is 10, I think 22. So I'll look for if 11 is there. If 11 is there, I know that some elements are already there, right? So yeah. So public boolean solve nums int I int target int 10 is equal to nums dot length while for int I is equal to 0 I less than nums dot length I plus plus. Array, what I'm doing? If I is greater than you return 0 or return false. First of all, if target is equal to 0, return false, return true. Basically, you have found that. Or less than 0, then you return false, right? Now, if this is not the case, then you say that you have boolean option 1 equal to false, boolean option 2 is equal to false. If now if the option 1 is equal to option 1 or you take it or you don't take it. This is very easy. I like to call out Aditya Verma. I learned this back when I was in college 4 or 5 years back now. He's one of the nicest guy out there. Huge respect for him. I've learned a lot but never gave an interview. I got selected to some. Where's my- But no, no, so here you are not taking this, right? Target remains the same. I0 should give TLE. Mm-hmm. Let's finish this for 23 DP. Yeah, TLE was expected. So DP is equal to new integer, and then that is either num.length or target plus 1. Cool guys, I think this is it for today. I was only able to solve two questions, but yeah, that is good. I got distracted in the middle. Not enough. Okay. Multiplication equals subtraction. Whether your day is easy or hard, still we have to do the same every day. Hey, 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 hey. Is it up? Okay. Uh, cool guys. Bye bye. Have a nice day. Thank you so much.